Hi, welcome. My name is Patricia Jordan. I'm a marketing specialist here at Interface Engineering. We want to welcome you to our 2025 educational webinar series event, Autonomous Agents, How AI Will Transform Virtual Meetings. Thank you for logging in and joining us today. We're using a GoToWebinar meeting platform, and our presentation today will be recorded and made available through our website and posted on our YouTube channel. All audience microphones will be muted during the presentation, but please feel free to enter your questions into the questions field. There's two different versions, a web version and desktop version of this GoTo platform. And the screen you're seeing right now is how you access those questions controls. Interface Engineering is an approved AIA provider, CTS provider. For today's participation, you'll earn 1 learning unit credit. All attendees will either receive a course completion certificate, or if we have your AIA number, attendance will be reported for you to AIA within the next 2 weeks. We'll leave about 10 or 15 minutes at the end of the webinar to answer any questions you may have. And if we don't get to some of the posted questions, we'll make sure to distribute a Q&A summary to all. I'll now turn it over to our Associate Principal and Senior Technologies Designer, Kelly Miller. Thank you so much.
Good afternoon, and except for if we have anybody in Hawaii, good morning still. Otherwise, thank you all for joining us today. Let me start with an overview of our firm. So Interface Engineering is a longtime mechanical electrical consultancy known for our sensitive resource use, advanced building science tools, commissioning services, and we focus on innovative engineering solutions for high performance projects. We really focus on sustainable designs that will not only perform beyond expectation, but also lead and inspire. These are our services. As you can see, we have the full range of consultant services here in building design. And we have offices for licensed in 45 states. We have offices across the country, and we've done work practically everywhere, except for looks like Nebraska there and Arkansas, maybe 1 or 2 others in the Northeast. So we are omnipresent. 275 professional engineers, designers, analysts, energy modelers, and administrative staff. And we've also done work, a lot of work outside the United States in 98 countries around the world. And we really focus on sustainable design, from zero energy to carbon neutral and beyond. Obviously, there's a cost savings that's involved, but just as important, it's about being a good steward of our environment and providing buildings that are not only going to last, but are going to be good for the people around them who live around them. The course description, what we're doing today is we're going to be looking at a subject which I'm sure you've heard very little about, artificial intelligence. And of course, that's a joke. And we're going to be looking at it specifically in my area, which is conferencing and collaborative technologies and the way it's helping to revolutionize the workplace meeting environment. And then we'll look at a project I completed. I've been with Interface now about 8 months, just before I came to Interface for the California State Teachers Retirement System headquarters. CalSTRS, as they're called, is the 2nd largest pension fund in the world behind CalPERS, which is the California's employee pension fund, and they're located here in West Sacramento, California. So the objectives today, obviously, AI is a very complicated subject, and it's involved in a lot of things. So we're going to keep it simple. I want people to come away with a basic understanding of artificial intelligence, fundamentals of how it works, as well as the differences between the AI subsets like machine learning and deep learning. We want you folks to learn how AI is being used today in simple to complex application. An example, take a look at some examples of it around us in our everyday lives. And we'll also review some keys for how to recognize it. Attendees will also learn how AI is being integrated into meeting room technologies and the way it's customizing the in-room experience, automating many processes, and changing how people collaborate in real time. And last, attendees will learn about the strategies for the meeting environment of the future, and in particular, how do we set up our clients to be able to use technologies in the future that they don't even know exist today, much less realize that they're going to need them. So for today, we have essentially 4 different areas. What is artificial intelligence? How AI learns, AI in virtual meetings, and then last, a project profile. So what is artificial intelligence? Well, simply put, it's a branch of computer science focused on creating systems or machines that can perform tasks that are typically require human intelligence. They're trying to create a computer-based version of the human brain. What does that entail? It means being able to learn from experience. And experience in this case is data. Recognizing patterns, such as images or faces. Understanding language in images or speech. Making decisions or solving problems. And also being able to plan or adapt to new situations. In short, AI is about building systems that can think or act intelligently, more or less mimicking the way humans process and respond to information. And I got that, of course, from GPT. So you can divide artificial intelligence into 2 categories, one by capability and the other one by functionality. So let's take a look at capability first. Narrow or weak AI is simply a AI that's optimized for a single task. So in this case, it's really much of what you know around you as being AI driven, whether it's Siri or Google Maps or recommendation systems, image recognition, autonomous automobiles. The second is general or strong AI, or sometimes nicknamed AGI. And it has the ability to understand, learn, and apply intelligence across a wide range of tasks, human-like intelligence and ability to self-teach. So it's largely theoretical, but this is the next horizon. And it's the one that most people allude to when they're talking about some of the future projects, particularly anything that involves your human-like capability to do multiple different types of tasks. And then last is super intelligent AI, which this is the one that surpasses human intelligence in all aspects. On one level, it's spectacularly exciting because it can do things potentially that we can't do. On the other hand, it's also very terrifying to a lot of futurists who worry about, if you've seen the movie Space Odyssey 2001, you know, our AI machine becoming HAL and taking over our spaceship, as it were. So, but at this point, it's purely conceptual. So artificial intelligence by functionality. Let's start with reactive machines. So reactive machines are really the most basic AI. It reacts to input, but has no memory itself. And probably the first main AI machine that most of us was brought to most of our attention was Deep Blue, IBM's famous computer that they developed simply to play chess. In this case, against Garry Kasparov, who was the reigning world champion. And at the time he retired around 2000, was generally considered the greatest chess player in history. And so Deep Blue was initially developed in the 1980s as Deep Thought, and it played Kasparov for the first time in 1989 and lost. And then they changed the name of it to Deep Blue in the 90s, and it played Kasparov again in 1996 and lost. And then by this time, they beefed up the processing power in it. And in 1997, it finally won. So it's important to understand, though, Deep Blue was programmed by IBM scientists and grandmaster chess players using 700,000 grandmaster matches to develop the rules and variables by which it would play. So while Deep Blue could play a great game of chess, what it didn't actually do was actually learn how to play chess. And when we talk about AI today, we're talking about machines learning, not simply being programmed to do something. Now, limited memory AI is what we mostly know today. And these are systems that can use the past to make decisions. So it's experience-based. They have memory. Again, it's most current systems, including Amazon Alexa, autonomous cars, chatbots, medical devices, imaging, There's a lot of AI now in imaging, looking for cancer, the things that AI-driven imaging machines can spot that the human eye can't do. So it's become a very powerful weapon in diagnostics. And it's important to understand, just because it's a single task limited AI doesn't mean it's not sophisticated. So let's just talk about our friend here, Waymo. Google started actually testing their autonomous cars in San Francisco in 2009. So almost 16 years ago now. By 2016, still testing, by the way, they had reached 1.7 million miles of driving of these types of cars. And those of us who live in certain cities, and I live in San Francisco, have seen these for years. So, and up until recent time, we saw them with a driver with them. So by August 2021, Waymo began offering a test service with a trusted tester. The trusted tester was the guy sitting in the passenger seat who could also drive the car. And by August 2023, Waymo finally, 14 years after they really began actual testing of this car, began offering commercial taxi services here in San Francisco. So we're gonna actually take a little poll right now, and the poll is, have you ever ridden in a Waymo or other self-driving car? So would you do me a favor and take a look at that question and respond to it? Should be able to see it down there in the polls area. All right, we're not getting much response here, but I'm going to give it another 5 seconds. 5, 4, 3, 2, 1. All right, well, that didn't do so well. They're interesting to write in. So if you ever get that opportunity, you should do it. And they're very sophisticated. So they used what's called level 4 autonomous. These cars are assigned different levels depending on the sophistication of their technology. And Waymo was what's called a level 4 car. The next category is theory of mind. So this is the sensitive, understanding, compassionate AI that understands emotions, beliefs, and intentions. And this is very much in research. And the last category is self-aware AI, which would probably put them beyond about 80% of most human beings. So it has its own consciousness and self-awareness. At this point, it is purely theoretical. So how does AI learn? Well, first of all, AI is a larger umbrella under which there are a couple of smaller umbrellas. One is machine learning, and the smaller umbrella under that still is called deep learning. And deep learning is considered the most sophisticated of the AI learning processes right now. So machine learning is an AI process in which computers learn from data without being programmed. However, they do require some human intervention. So let's take the car, for example. We want to train our AI machine to be able to identify a picture of a car, or at least the description of a car in this case. So we're going to have to take our car picture, we're going to have to extract the features out of it, and then we're going to feed it into our AI machine, which is then going to do its processing and classification. The outcome will be whether or not it's a car or not a car. Now, here's a great example in your everyday lives of what machine learning looks like. Your spam filter for your email application. When you have a piece of mail that comes in and you tag it spam and it goes back into the system, you are informing the AI, the artificial intelligence processing that's behind your spam filter to identify this as spam and look at the features that are in it so it can recognize it the next time it comes through. Conversely, if you go into your spam filter and find a piece of email you should have gotten, and now you tag that one as not spam and feed it back to the system, the algorithm that processes your spam for your email will again look at the features for this guy and then not make that mistake in the future. And that's why it's really important to tag your spam, because if you just delete it, you're not helping to inform your system and help it learn. Now, deep learning is a process in which multi-layer artificial neuron networks process data to learn complex patterns. Human intervention is not generally required. So again, back to our car example. We're just going to feed the picture into our AI machine we'll take a scan of it. It'll do its classification and processing on its own. Doesn't need to be told anything more than that. It's using its learned history. It's looked at pictures before. It's got some information already, and it's going to decide car, not car. So a simple illustration of this would be our cat drawing here. Our AI machine will look at that, see the ears, see the eyes, tail, whiskers, paws, and the fur, and it would then know that's a cat. Once you've got your AI machine set up and running, it's going to have a development life cycle. By life cycle, I mean it's going to be in a continuous circle of information gathering, preparation, processing, and deployment that powers the AI machine's constant improvements. Now, here's an example of a product that I think probably many of you have, the Amazon Alexa Echo, which was started in development in 2009. Amazon launched a very skunks work AI branch within their organization that they kept secret, so people did not know what they were working on. It took 5 years, and they issued the first Echo in August or so of 2014. So when your user speaks to Alexa, it is data acquisition. And now using algorithms, automated speech recognition, and natural language understanding, Amazon's AI cloud converts the audio into text. That's data preparation. And it does this before it can actually do the analysis. Now the AI analyzes the intent and details of the text inquiry and formulates a response. And that is the evaluation and interpretation phase. Text-to-speech converts the response back into an audio clip to play on your Echo. That's deployment. It does it all in well under 2 seconds. So Amazon, this obviously takes a lot of processing power, and that's why people who've been in the architectural industry and design have seen so many projects for data centers over the last 3 or 4 or 5 years in particular. These are data centers being developed largely to support AI machines. And Amazon, by the way, for those of you who own one, you should know that you once had an opt-out for your Amazon Echo, in which you could opt out so that the only audio that would go into its system would be when you were addressing it directly. Well, that opt-out doesn't exist anymore. So Amazon quietly got rid of it about 3 weeks ago. So those of you who have these in your house, you should understand that everything you say, every conversation you have, every piece of audio that goes on in your house gets transmitted to Amazon's AI cloud. And you ask, why would they want to do that? Well, the fact is data is king, and data is particularly king in AI because that is what forms the learning life cycle. Now, what do you need to make a device potentially AI compatible, or at least an AI-driven device? Well, first of all, you need some computer processing locally, which is virtually anything you buy these days that has a battery or has a plug. It's probably going to have some computer processing in there, running the controls for it, remembering things. If you buy a tabletop appliance, a lot of them have computer and internet access these days. It's going to need memory either locally or in the cloud. And then last, it's going to need cloud access. It's going to need Wi-Fi. It's going to need some type of connection so that it can converse with the cloud and do that life cycle thing. That is most things. That's not to say most things are being AI powered these days. That's not true. But most things are capable of being AI powered. So let's get to AI in the virtual meeting space. AI and virtual meetings, the impact on the technology itself, the stuff we're putting in our rooms, the stuff we've been putting in our rooms for about the last 30 years, more or less. The experience of the users, and also the behavior of the users, the behavior as a group. So the goal of the technology and AI is to make the technology self-reliant, proactive, and inconspicuous. AI-powered meetings promise to create a more uniform, equitable meeting experience for all attendees, be they in person or remote, and break down the traditional technology barriers to active collaboration. So what are those barriers? Well, one is accessibility. To this day, making complicated things easy to use has been a challenge. What makes something like an iPhone such a piece of, a work of art is that they literally don't come with instructions, and yet everybody seems to know how to work them. And yet we still go into conference rooms these days and struggle to make the relatively simple technology work. And then also the quality of the content sharing. We still have struggle with audio in these rooms. People not being able to be heard, not mic'd properly, evenly mic'd, background noise that interferes with the signal, video cameras that don't move around, that stay fixed in one position. So one guy's on camera all the time and everybody who's off axis is never on camera. And then the produced content itself, partially because of the limitations of the content applications. We make content. In this case, I made this presentation today based on what I think would be interesting largely to me. Now, of course, I've thought about you folks, and you're sitting out there, and I'm hoping you're learning from it, and it's interesting to you too, but it definitely makes sense to me. But in an ideal world, this would be repurposed so that it definitely makes sense to all of you too, regardless of how you individually learn. Let's talk about accessibility first. Setup. Is that what you're talking about? The equipment will self-configure, monitor, and readjust itself based on room conditions, users' preferences, and meeting profile. So ideally, you should not be having to go back into these rooms anymore and start setting stuff up. It will know. And if you're using, we'll talk a little bit about this too, if you're using an application like Teams and setting these rooms up as part of that, it should start identifying who's using these rooms, whose meetings these are, and then start adapting their profile when they go to use them. Operations, in addition to conventional touch controls, which have been around for about 30 years, you'll be able to operate these through voice commands, just like your cable TV has changed. A lot of folks now at home don't sit there and hit their clicker or their the remote and punch in their numbers. They simply hit a little microphone button and then call out the channel they want. Gesture control, facial and hand, including sign language, shaking your head at the monitor, letting it know it's on the wrong slide, for example. Predictive device management. This is about the system eventually figuring out what you're going to do next, right as you're beginning to do it, and making the technology change for you. So I'll give you an example. You get up and you go to a whiteboard. Well, the system's already knows there's a whiteboard in the room, so it sees you walking to the whiteboard and automatically shifts its camera over to the whiteboard. And this is all, again, this is deep learning, machine learning. And then language, being able to offer real-time translation and closed captioning. As we move into a global world and we have people in different countries and different languages and that, it's not sustainable to simply do our meetings in one language. We've got to be able to offer what people are used to real time. On the audio side, beamforming microphones is sophisticated microphone technology that's been around about 20 years. The Amazon Echo that we talked about earlier uses a beamforming technology. If you've ever talked to one, you'll notice a little blue light on top will kind of aim in the direction that you're at. And if you talk to someone another direction, it'll aim at that direction. Well, that's one of the microphones that are in the array, actually figuring out which one's closest to you and then essentially shutting the other ones off so that it can target you. And that's the way these guys work. A lot of times nowadays, they come on a single 2x2 sitting tile, and so they look like a tile in the room and that, but they're actually an array of microphones around the rim of the tile. Now you couple that technology with AI, and it's going to be able to identify the speaker by name. Be able to lift the voice to level volume. Leveling volume across multiple voices is a real key to what's called tempering bias. And we're going to talk about that a little bit later too, but it's part of the solution. It's going to be able to filter unwanted background noise like AC or paper shuffling, and then eliminate echoes as well. Another problem that 30 years later we're still dealing with. Translate the source language into preferred language of other participants. We've talked about that. And translate into closed captioning, generate a transcript and a summary of the meeting. On the video side, there's a term being bandied about in the AV world called visual AI or intelligent video, and they essentially mean the same thing. But these are cameras that are coupled then with AI to be able to do a lot more than they've traditionally done in the past. First of all, they're going to be able to read the room. By read the room, it means it's going to be able to recognize when it's occupied. First person that walks in, they're going to know somebody's in that room, and they may launch the monitor display, for example. They may turn on the lights, they may close the blinds, whatever it's set up to do, whatever it expects you to do as part of your meeting, it'll accommodate that. It's going to count the number of attendees and then map out the seating layouts. So it's going to know where you're all sitting. It's going to facially identify the participants. Now, of course, this is going to be in organizations that have a regular workforce using that meeting room. If you bring somebody in off the streets, obviously it's not going to recognize that person. But if you're the same folks, the same 20 people, using that room 5, 10 at a time, then it's going to start identifying who's there. And that's key because that's going to show up in the transcript. So, when the transcript's broken out by what everybody says per person. And then it's going to notice other potential content sources, like I said, like a whiteboard. It's going to auto adjust for room lighting and speaker complexion. It's going to auto track and frame speakers by face and voice recognition. And you can see here in this illustration from Cisco, what they're telling you is the guy on the left is sort of using his hands, and he's both speaking and using his hands at the same time. And so the camera has pulled back to a wider angle to sort of capture all of his upper body. Whereas the gal on the right, her hands are down and she's just speaking, so it's zoomed in on her face. It's going to also be able to filter unintended or unwanted background images, like the Google phones that you see, commercials you see where they get rid of the guy who photobombed in the back. It's going to potentially identify someone who should not be in a meeting, and this happens. You work in certain organizations and financial organizations and research labs and whatnot, and you have proprietary meetings in which only the people who are there can be there. And so, occasionally someone pops in or shows up remotely or whatever that doesn't belong in that meeting. The visual AI or intelligent video AI will track them down and kick them out. It's also going to recognize where the room is no longer occupied, which may, if you set it up, cause the virtual machine that's displaying any content to wipe it from the display. We'll talk a little bit more about what a virtual machine is down the line here. But that's important for security reasons. You don't want somebody coming into your meeting after you're gone and being able to pull up proprietary content that you've been looking at. And on the produced content side, you can start with the fact that there are AI-based apps right now, like Gamma, that can create your presentation entirely from scratch for you. I did not do that, by the way. This is what I made. AI can personalize prepared content delivery to better serve the learning preferences of individual users. It can provide supporting or clarifying content, a chat text, web links to articles, photos and videos, charts and other data, avatar experts alongside the presentation. The experience of being in an AI-driven meeting and technologies environment will be to automate and optimize most of the functions users are now tasked with during meetings, making the technology largely organic and proactive. Right now, it's responsive. You need to go in and make something generally happen if you want it to happen. Individual user preferences, if you're using a room over and over again, will also be learned. And settings for those environmental parameters will be configured automatically before the beginning of the meeting. We integrate the systems in with, for example, the building management system that allow AI to structure custom environments for each meeting. So if you work in a facility that has multi-purpose rooms, as we call them famously, where you have room dividers and that, and the rooms can be combined and decombined, based on how many folks you got coming. Well, this will happen automatically. It'll look at how many people you've got coming to the meeting, and it'll automatically combine or decombine the rooms, and it'll do all the electronics at the same time. So the sound system will be one sound system. Displays will also show the same information and that kind of thing. You might want to use sound masking as a way to provide, if you're again working in a environment, financial services or a pharmaceutical company or a lab of some sort, or certainly technology companies as well, where you have proprietary information being discussed, you can install sound masking outside the room along the corridors and have it automatically engaged to make sure that people walking by the door cannot hear, or at least they can hear, but they won't be able to understand what's being said inside the room. You can automatically set temperature and humidity settings, and lighting and shades. And again, the AV equipment functionality and levels will all be predetermined based on how the room's been used in the past. Now, on the behavior side, according to the Harvard Business Review, there are 4 different characteristics of a successful meeting. One is personalized content tailored to learning styles. Second is purpose alignment, bias detection and prevention, and then collective and individual learning promotion. Personalized content. AI will tailor content to the unique learning style of each participant. Visual learners, auditory learners, etc. Users will be able to chat with a generative AI companion or tutor during and after meetings to better understand the presented content. And that sounds far-fetched, but Zoom is actually testing that today. Bias detection. Now, bias can manifest in meetings in very subtle ways, just as it does in organizations. Men often speak louder, so people like me might get more attention than some of the other folks in the room who speak softer. Cameras may spend more time on certain individuals while ignoring others, particularly cameras that are user-driven or user-operated and don't move around in the meeting. A lot of times they just sit there and they never move. So the person who's at the front of the table or center of the table might get all the camera time, and the people who sit on the edges never on camera, even when they're speaking. So generative AI is being tested as a method to help HR organizations both monitor and provide real-time intervention to temper bias in meeting situations. The goal is not to intrude, it's to provide a nuanced moderation to support inclusion and equity goals. So that may mean leveling voices so that the guy is not louder than the other people, and bringing those voices that are quieter up so that they're the same level. It may mean moving the camera around or linking the camera with the voice so that it always follows who's ever talking, which is pretty common nowadays. So it's the idea is that everybody should be equally represented in your business meetings. So learning promotion. The AI will be able to provide real-time discovery. So what that means is your AI engine in your meeting will be sitting there listening to your meeting go on, and then it may figure at some point it's got something to offer. So it may proactively provide relevant information in the chat window. Your AI bot may act as a personal coach and follow up with different individuals and help them develop their presentation and engagement skills by providing feedback. And then lastly, your AI bot may aid in measuring and proactively addressing team dynamics and health. You know, teams are together, as we in our industry, of course, we do projects, long-time projects that can take years. They're together for a long time, and teams typically have, you know, ups and downs as they go through it. And we get periods where everything's rocking, and then we get the periods where things are slogging. And AI is going to ideally help us level that out. This is a project survey, and this is the California Teachers Association Retirement System, again, nicknamed CalSTRS, in West Sacramento, California. This was a 250,000 square foot, 10-level building here in, again, Sacramento. It's got all kinds of facilities in it. So it's got obviously meeting room, conference rooms of various sizes, from huddle on up to large conference room. It's got an event center, so where they can hold hundreds of people with large, you know, big displays and whatnot. So video walls, LED, direct view LED video walls. It's got a production studios next door, so there's another tower next door, and we have cameras in the new project. Then, for example, the event center that are broadcast grade cameras, and there's fiber that links back so they can produce events from the event center and use their actual production studios in the other building. They have cable TV distribution throughout, and they have a lot of digital signage, you know, employee-based, and they do stuff for like monitoring building energy use. You'll see monitors showing how the building's doing and whatnot. So one of the first questions I ask for a big deployment like this is I'll ask, are you a user of any particular application? Are you working much in the cloud? Because that's where it's really all happening. So whether they're Microsoft 365 and Teams, Google Docs, Meet, Zoom, that's where all this stuff is being deployed. So in the case of CalSTRS, they were already an Office 365 user, but they really weren't doing much with it. They were still coming into their meetings with their laptops instead of using SharePoint to keep their documents on and plugging them in and plugging in, using their laptop as their video conferencing engine. So they'd have to plug the camera into it and the microphone into it and figure out how to get a speaker up and running. So pretty klutzy. But bottom line is they had the platform. So they were ready to go. And Microsoft has actually been developing apps for years that do some of the things we're talking about today. For example, Azure does translation. Cortana, for those who remember, was actually the application before the Copilot application. This was the digital AI assistant before it was finally retired and Copilot came out. And then, of course, Teams has become the center for all of its group meeting activity. So they already had the stuff available to them to start doing this stuff. So what we did is we decided to put them at least in the position to be able to do these things in the future if they weren't ready to do them now. And that meant AV over IP architecture for the entire building. So all the systems I described earlier all run audiovisual over IP protocol. So conceivably, we can take any video source and audio source in the building and send it to a display anyplace else in the building. It's not the way it operates. You ultimately configure that based on how the building gets used, but that is, from a design standpoint, possible. And then they have in all their conference rooms, they have LCD displays, touch displays with Windows 11 embedded PC client that's running what's called a virtual machine. So what's a virtual machine? Well, a virtual machine, and you may have one running right now. If you run a Mac like I do at home, and then I want to run Windows, which my company uses, I still want to use my Mac, I run a virtual machine that I can run Windows in. But the bottom line is, for this application, what it means is you can run apps remotely without having to install them locally. So you get access to all the apps that are available on the servers, the company servers. But the important thing about it is it's great for document security on shared computers. So again, as we talked about before in the conference room experience design phase part, if people leave the room, you can program it so it'll know people are gone after 10 minutes and it'll wipe the monitor of all the content so other people can get to it. So displays actually sit on the local area network like a PC. So they're completely managed by the IT department. And from their standpoint, it's just another PC. And from the user standpoint, it's a person to invite to the room. So when they schedule that room, they schedule in the display that's part of it. And so it's part of the meeting. And we made sure they all had visual AI enabled cameras, so they could take advantage of some of the features we talked about earlier, even though they weren't ready to do so yet. And every room is equipped more or less with the same functionality. What changes is the scale. So if you have a large conference room with 15, 16 people sitting in it, you maybe have 2 monitors, 85 inches, 86 inches each. If you're in a smaller room with 10 people, you may have 2 55s. So, but the purpose was to make sure everybody walked into any particular room and it would look similar in terms of the way it operated and the things it could do. So when a user at CalSTRS goes to use a room, they walk into it, the system recognizes that someone's there. They log in using an MS authentication app, just like you do on your phone. Meeting docs are stored on a server, are made available to the room's virtual machine. The lights and shades are automated by the audiovisual system. And then MS Copilot keeps meeting notes and writes up a summary and suggests next steps at the end of the meeting. When they leave, the system recognizes that they're gone and wipes the virtual machine in the display of all meeting documents, keeping the meeting secure. So what's the summary of all this? And I realize I've thrown a lot of stuff at you, but like it or not, AI is here to stay. There are certainly downsides, security and privacy concerns, AI, what's called hallucination, which simply means AI sometimes just makes stuff up. So in a meeting, it's really hard to truth test your AI because you don't have time to. But sometimes it's just gibberish. And information overload. If you have bots going on the side and you have things being thrown at you while you're in a meeting, that might be an issue. The demise of individual creativity and critical thinking skills as people become more reliant on their virtual friends. But the ability to create highly engaging individual experiences that are traditionally mundane group interactions rather, is too promising to pass up. And who knows? I mean, maybe one day your avatar will be able to attend the boring meetings for you while you'll be out having drinks with your coworkers down the street. Wouldn't that be a great day? So thank you. That concludes my presentation. I want you guys know that the next iteration of this to be details to follow will be Wind, Sun, and Salt, and No Day at the Beach for Designers. Roger Fischette and Keith Pazda will be presenting that. And let's open it up to any questions here in the question area. I guess the poll didn't show. Yeah, we had an issue with the poll. I apologize for that. I will, let me see, I can't run it again. I am gonna ask you another one though, for those of you who are still on. Let's see if we can get it this time. Have you ever used Microsoft Copilot in a meeting? Oh, I just submitted that one. Oh, I'm getting answers. So we got news. It's good news. We got, oh, wait, we had 72% said no, so and 28% said yes. I'm not going to ask you here, but I'd like to know what people think of it. So obviously it's it's something they've been at it for a while, and Copilot's the new version of it. And that, I'll tell you, my wife loves it, and she uses it for her meetings. So let's take a look. Are there any questions out there? I see the poll ones. Okay, what is your experience with having AI take meeting minutes? We just talked about that. It actually does again, we'll go back to Copilot. If you try Copilot, if you're an Office 365 person, you can get Copilot for free and you can run it. And it does a very good job of taking meetings, actually. There are other ones, by the way. There's one called Otter AI, which is a separate, this stuff's all kind of moving fast. And San Francisco, where I live, is kind of the ground zero for AI in this country. But there are a lot of small companies at this. Otter AI is another one that's doing translation in that, that's integrating with other apps. Any other questions out there?
There's one more, Kelly. Did you see that?
Yep, I do see it. What is your experience with AI meeting notes tools when some participants oppose the use of AI in the process? Well, I mean, I think there are a lot of things that you do in meetings, recording them, for example, where people, and a lot of times don't get a vote, to be honest with you. Slide back up there. That's really an organizational thing more than anything else. Obviously, that's not a technical thing, technology thing. That's about setting. And at some point, I think organizations that do start to use this in any serious way, and let's talk about, again, facial recognition being one, so that you can pump out, meeting a transcript at the end, per person. So everybody's is identified, and then what they said is right next to them. That's going to take some buy-in from people. Not everybody is so thrilled about the idea of a camera being able to recognize them when they walk into a meeting. So that's going to take some organizational norms to be established. It's going to have to be, there's got to be some rules. There's going to have to be buy-in. It's going to have to be, management driven. Because that's really change. We're talking about change management now. We're not even really talking about the technology. And that's a That's a challenge regardless of what you're trying to implement in an organization. And there will be a lot of it implementing this technology. Anything else? All right, Patricia. Well, I think we're good.
Yeah, Josh had a couple other questions about if
Okay.
the participants of a meeting are not part of the organization, clients or guests, can you turn it off meeting by meeting?
That's really the way, that really goes to how it's implemented. But yes, conceivably you could. That's gonna be part of your implementation plan. If you do a lot of work with outside folks, then yeah, that's something you definitely would want to be part of your implementation plan.
Great. Thank you so much, Kelly. Thank you everyone for participating in today's webinar. We hope it was informative. If you have any suggestions for improvements, please send us a note. We appreciate it and look forward to seeing you at the next webinar. Thank you and enjoy the rest of your day.
Thanks again.